earlier this week in 7.1, we talked about quadratic functions and we looked at their graphs, the parabolas, the different key features. And then in 7.2, we talked about the quadratic formula. Here it is again, the quadratic formula. If you are given a quadratic equation in standard form, that's ax squared plus bx plus c, you can use quadratic formula to solve for x. Okay, and remember that what we're solving for is representing your x-intercepts when we graph it. Okay, when we did this in 7.2, we always came out with nice rational answers, meaning integers or fractions. Okay, pretty rational numbers. Now, today, we're going to look at it with values that we're going to come out to decimals. Okay, so these are going to be irrational numbers that we're working with, but the process is the same. So let's review the process. The steps are going to be to first identify what is your ABC. Remember, those are the numbers. A is the coefficient in front of x squared, B is the coefficient in front of x, and C is the constant. Okay, so identify your ABC and calculate the discriminant. Remember, the discriminant is what's under the radical. It's that portion that's in red here. So let me highlight that for us. Highlighter. So that all the way to C. Okay, well, not that. Let's try that again. Why won't it let me highlight the C? That's weird. Come this way? Nope. Okay, whatever. You get the gist. The part under the radical, that's the discriminant. That's what we're going to calculate first. Now, that number, if you look back at your 7.2 notes, we talked about how the discriminant will tell us how many solutions there are going to be. It's either going to be one real solution, there's going to be two real solutions, or there will be two complex or imaginary solutions. Okay, so complex is imaginary, if you want to write that above it to remind you what that is. Okay, and this happens if you get a negative for the discriminant. You'll get two real numbers if you get a positive for the discriminant, and you'll only have one real answer if you get a 0 for the discriminant. Okay, and again, you can look back at 7.2 notes. We went into that in more detail. Now, if the solution exists, if it's not going to be, if you don't get a negative under there, then we're going to go ahead and solve. Okay, we're going to simplify the square root if possible, and then simplify the fraction if possible. So let's jump into some examples here on the back. Okay, in this first example, I need to identify A, B, and C. Okay, so those are the numbers again. So A does not have a coefficient in front of it, so it's what? An understood 1. Okay, if there's not a coefficient in front of the variable, it's understood to be a 1. So A is 1. In front of the x is -8, so that's my B. And then my constant is +5. Once you identify your A, B, and C, we're going to find the discriminant. So B squared minus 4AC. So we plug those in to this expression. Okay, you get to use your calculators. If you don't want to do that in your head, you don't have to. So we end up with 44. Is that 64 minus 20? So 44. That is a positive number. So how many solutions will there be when we get a positive number there? Positive means there will be two real solutions. The reason it's two real is because this number is positive. So we're going to have two real solutions. So we're going to go ahead and finish solving this using quadratic formula. So we have x equals, and then it's negative b. Now b is the negative. So now we have a double negative because there's a negative from the equation, and then our b value is negative. So negative b plus or minus the square root. Now, under the square root is what we just found there. The discriminant was 44. We've already simplified that. And it's all over 2 times a. Our a is 1. So I'm going to simplify this. The double negative, so that's going to become a positive 8. Now 44 is not a perfect square. I can't take the square root of 44 and get a nice pretty number. In my denominator, in the bottom, I can go ahead and multiply 2 times 1. That's just 2. Okay, but I don't know the square root of 44 off the top of my head. So I will go ahead and use my calculator and get it as a decimal. That's what the notes are called today. They've got decimal in them. So we're going to be dealing with decimals. Now remember, because of that plus or minus, I'm going to have to separate this out. I'm going to have to do it once with a plus and once with a minus. So I'm going to calculate these because of that plus or minus, once with a plus, once with a minus. So I'll pull up Desmos here. It is 8, and actually I'll go ahead and get the fraction first and then type in the top 8 plus, and then your square root is right here, 44 over 2. Now you can just copy and paste that and change the plus to a minus, or you can retype it all, it doesn't matter, but this is what I get. I'm going to split screen this to write those answers. So we got, for the plus, it was 7.3. Now, did they tell us what to round to up here? It did not. So let's just take it to the tenths place. That's 2 places, or let's take it to the hundredths. 2 places after the decimal. So we're looking at this 1. That's where we're going to round it to, but you always check one more. So the 6 is going to round that 1 up to a 2. So this will be 0.32. And then I'm going to say, I'm going to make my equal signs a little wavy. That means approximately. With the minus, it was 0.6. And then I'm going to look here. 8 is where I'm the one that I'm rounding, but I've checked the 3. 3 does not round that up, so it's just going to stay an 8. Now, I can confirm this graphically, meaning I can check the graph of this original equation that was given, which was x squared minus 8x plus 5. That was it, right? Let me double check. X squared minus 8x plus 5. I can look at this graph, and what do you see? What is the decimal at the x-intercept? Those are the values we got with quadratic formula, aren't they? So you can confirm this graphically. That's why it's so important you understand what you're solving for. When you are solving equations for x, that represents the x-intercept. So graphically, I can look at the x-intercepts, and those are my solutions. You'll feel okay about that? All right, let's try the next one. Full screen again. All right, so what is A?
3.
Just the 3, yeah. The A, B, C are just the numbers, no X's. Okay, B?
-5.
Very good. And C?
1.
Perfect. So now I'm going to calculate my discriminant. B squared minus 4AC. And I can type that into the calculator just like that. Make sure you use the parentheses so that the negative gets squared as well. And we end up with 13 as our discriminant. Is that a positive, a negative, or a 0? That is a positive number. So what number of solutions should there be? We get a positive discriminant. It's 2 real solutions because it's positive. If it was a negative, it would be 2 complex. If it was a 0, it would be 1 real. Okay, so we've got that. Now I'm ready to finish solving using the quadratic formula. X is equal to negative b plus or minus the square root over 2a. And under that square root, we just calculated it'll be a 13. Okay, I don't have to rewrite all of that. I already said it's 13. I'll just write it as 13. So then I simplify this. That's going to become a positive 5, again, because of that double negative. Plus or minus. 13 is not a perfect square, so I'll leave it as a radical. And 2 times 3 is 6 in my denominator. So now, again, because of that plus or minus, I've got to separate this. I'm going to have to do a plus and a minus because there are 2 solutions. I should be separating this and solving twice. Again, the difference here is a minus and a plus. We have to calculate both. So I'll pull up Desmos again. And I type that just like I see it. So x plus the square root of 13 over 6. And then you can rewrite it on the next line or copy and paste and change it to a minus. And these are my 2 decimals. So that is for plus 1.43 because I looked to see if I needed to round that 3 up. A 4 does not round the 3 up. And then this will be 0.23 because that 2 does not round that 3 up. So 0.23 for the minus. Okay. Check the next one. All right, here we go again. Same as on 7.2. We got to a couple of examples that are not in standard form yet. So I need these to be set equal to 0 so I can identify A, B, and C correctly with the correct signs. So to move this minus 10x over to the left, what would I have to do? So it's going to become plus 10x on the other side. What about this minus 1? I'm going to have to add it to the other side. So I'm going to end up with 5x squared plus 10x plus 1.
You have to always change it when it's like negative?
Yes, whatever it is. If it was a positive on the right, it becomes a negative on the left. When you're moving it across that equal sign, it's going to change signs. Okay, so this is standard form now. So my A, B, and C are all positive this time. So when I find my discriminant, I'm sorry?
Is that 2 real?
We don't know yet. We got to find this discriminant first and see if we come out with a positive, a negative, or a 0. So for a C. All right, now we've got, that would be 10 squared is 100 minus 4 times 5 is 20, so that's 80. So this is a positive number, So again, this is another one that's going to be two real numbers because I came out with a positive discriminant. So now I'm going to finish plugging these in. So negative b plus or minus the square root, and it's all over 2a, and a is 5 this time. Now what goes under the square root is that 80. And again, 80 is not a perfect square. So that means I'm going to get a decimal, okay, an irrational number. So I'm just going to separate this out, simplify it a little bit and separate it out. So that is going to be now a negative 10. And I'll do plus the square root of 80 over, and then the 2 times 5 is 10. And I'll do the same thing, but changing this to a minus square root of 80. So again, I kind of just took out one step here to save some writing. I'm going ahead and splitting it in the same step where I simplified. So now I'm going to type that in. So this is negative 10 plus the square root of 80 all over 10.
17 hours.
Then I'm going to do that and change this to a minus. So these are the two values that I get. They're negative. That's okay. Some people get confused sometimes. They're like, I thought we can't have negatives. You can't have a negative discriminant. Okay, if that discriminant comes out negative, your answers are going to be imaginary. But your final solutions, it's okay for those to be negative. That just means your x-intercepts are to the left of the origin. So this is negative 0.11 because here that 5 is going to round this 0 up, so it'll be negative 0.11. And this one will be negative 1.89 because that 4 does not round that 9 up. So these are what we're leaving it as. Okay. All right, last but not least, see what we get here. This one is not set equal to 0 yet, so I have to move some terms, just like I did before. The only thing I have to move is that 18. So if I add 18 to the other side, this is going to come out. I don't know why I just started to write that. My bad. This is going to be x squared plus 12x plus 18 equals 0. So my A is an understood 1, my B is a 12, and my C is 18. So this is 12 squared minus 4AC. Okay, and the 12 squared is 144. And the 4 times 18 is 72. So 144 minus 72 is 72. So we end up with a positive 72 here. So again, I know that that means a positive discriminant, there will be two real solutions. So I'm going to plug these in to the quadratic formula. I'm going to have negative b plus or minus the square root, then all over 2a. And under that square root is that 72. 72 again is not a perfect square. So I see this is going to be an irrational value. So we're going to have decimals again. So I'm going to go ahead and simplify this, and I'm going to go ahead and separate because of that plus minus. So this will be negative 12 plus the square root of 72 over 2. And when I say simplify, I'm talking about that negative and the b. That just comes out to negative 12. And the 2 times 1 in the denominator just comes out to 2. And we're going to do it changing that to a minus square root of 72. I did one with a plus and one with a minus. So we're going to type that in, negative 12, square root of 72, and the denominator is 2. All right, y'all have a good lunch. I'll finish this video typing these decimals in, or writing these decimals. So negative 12 plus the square root of 72 and negative 12 minus the square root of 72, both over 2. So that comes out to be negative 1.76. We have to round that 5 right here. That 7 rounds the 5 up to a 6. Here, negative 10.24. The 2 does not round the 4 up. So it stays 0.24. Those are our 2 solutions. Now, all of these, I only showed you checking graphically with the first one, but with any of these, you can plug. Once you have it set equal to 0, you could plug this in and see the graph, and then click on the x-intercepts and make sure that those decimals match. Okay, so now you're going to have a practice in Delta Math.